Good day, students. In this video, we'll discuss chapter 11 of your science, that is physics, electricity. This is our first video on this chapter. I'll just touch upon very basics and some interesting topics. This may not be directly academically related to what you see in your book, but I assure you that this will be interesting, and this understanding will help you to understand this chapter very easily. So now let us go to the points of discussion. We will discuss about atomic structure, electric charge, how a current flows. This is something which is very interesting, and direction of flow of current. So I just want to put one disclaimer here. Whatever I discuss now is not as simple as I say. I just want to introduce you to the concept of how really current flows in a conductor. For that, I am oversimplifying certain concepts and ideas so that you can understand and visualize it. The actual current flow is much more complex, and I'm sure that you'll be learning in your next classes, standards, or maybe in your engineering. But for now, I have simplified to the extent which you'll find it easier to understand. So to understand how the current flows, you need to understand the structure of an atom. See, I'm sure you must be knowing like atom has a heavy nucleus. Then there's something called as orbits. Within orbits, electrons revolve around. So the nucleus has a neutron and a proton. You can see the cluster of neutron and proton. That is the red and plus color, green color symbols. And electron is the blue color symbol which is rotating in its orbits. So two basics or some property I can say. Like charges repel and opposite charges attract. Means these electrons when nearby they repel each other, and positive and negative charges attract each other. So the positive protons in the nucleus, the positive protons, whatever you're seeing here, this will attract the negative electrons. So that is one of the property of the protons and neutrons. So this is the basic structure of an atom, which I'm sure you would have read in your earlier classes. And now I'm introducing a new concept called as free electrons. See, in metals, we'll see what metal in metals. There are electrons in the outermost shell, which is called as valence electrons. This is what I'm calling as the outermost shell, and these electrons are called as valence electrons. These are loosely bound. Loosely bound means I told you that they attract each other. The positive and the negative charges attract each other. But imagine there are 5 orbit. You have 2 here. Imagine there are 5 or 6 orbital circles. This proton will attract this first orbital circle with maximum strength. But the one which is in the 5th or the 6th circle, the proton will not be able to attract that electron with the same strength. It is weak. That is what it is saying, that they are loosely bound. See, the electrons, the outermost orbit electrons are loosely bound because they are far away from the nucleus, and they can move freely from one atom to another, thus becoming free electrons. But to move freely, they need a push. So what is that push? We will see. Since they conduct electricity, they are also called as conduction electrons. So you must be much clear on the 3 terms: valence electrons, free electrons, and conduction electrons. So let me show you with the example. So these are all good conductors of electricity: copper, silver, and iron. Okay, you can see each of these have 4 or 5 orbits. Okay, copper has 4, silver has 5, and iron has 4. And specialties, each of these have 1 electron in the outermost orbit, and this 1 electron is loosely bound in the strength, in the sense the proton in the nucleus doesn't attract this one so strongly. So the proton in the nucleus can attract this electron, can attract this electron, this can attract electron very strongly, but the outermost, it is not in a position to attract. So this 1 electron is free to move between one atom to another atom, but a push is needed. Without push, it cannot move. Okay. This is the concept of free electrons. Now let me introduce another two ideas, that is the electric charge. There are two types of charge. One is positive, that is the protons. Protons are positively charged and electrons are negatively charged which rotate in orbits. So the charge of the proton and charge of the electron are numerically equal, but the symbols are different. Charge, the unit of charge is coulomb. So you can see coulomb here. Okay, the unit of charge is coulomb. So charge of the proton and electron are numerically equal, but they are the direction or the symbol positive and negative is different. So this charge is a very minuscule value, like minus 1.6 into 10 power minus 19. So numerically when I put this, this is the value, like 1.6 into 10 power minus 19 is equal to this value. It's a very minuscule charge. Okay, so one electron has this amount of charge. Okay, now how the current flows, that you need to mix both the ideas whatever we studied now. One is free electrons, another is the charge per electron. So when we blend both these ideas, you get to know how current flows. We just saw that aluminum and copper have free electrons, that is one free electron. So these free electrons can move from one atom to another. A metal wire has large number of these free electrons, like a 1 meter wire will have so many free electrons like this. But they cannot simply move, they need a push. So let us see what is that push. The free electrons need a push to move through the wire. The push is provided by the voltage from the source of power, that is battery. The battery voltage provides the push. So we all know that battery has a positive terminal and negative terminal. Okay, when a wire is connected to a battery through a load, the electrons which are negatively charged in the wire get repelled by the negative terminal of the battery, and whatever is getting repelled, it starts moving from one atom to the other, which also carries the charge. The moving electron also has a charge, whatever we saw, right? Minus 1 power 10 power minus 19. So each of this electron, whichever is moving electron, the free electron which moves with this charge. Okay, but it is not one electron moving, it is plenty of electrons which moving, that contribute to the huge amount of charge. Not huge amount, that contribute to a meaningful amount of charge moving through the wire. Okay, so whatever gets repelled in the negative terminal gets attracted in the positive terminal. So the electrons move, and when they move, they are attracted toward the positive terminal of the battery. So I'm just visualizing, showing a visual. The internet, this picture is from the internet. I don't recall from which website I took it. So you can see here there is negative terminal, there is positive terminal, and a zoomed cross section. You can see these are the atoms, and the atoms have electrons in its orbits. And whatever violet color you see are the free electrons which move from across the wire, Okay, this is the path of free electrons which is moving across the wire, and these free electrons carry the charge which they have. When multiple electrons move carrying the charge, the electric current flow happens. So now we are coming to the closure, the direction of the current flow. As I told you, when we connect a wire between the ends of the battery, the electrons start moving, resulting in electric current. Okay, without that battery, the free electrons cannot do anything, it stays in the orbit. Only when you connect with the battery, the electrons start moving, resulting in electric current. So there is two direction of flow of current, that is the actual flow of electrons. Direction of flow of current, actual flow of electrons is from negative to positive. As you saw in this, the flow of electrons is from negative to positive, whereas the flow of current is from positive to negative. This is something very important you need to remember, because in your circuit diagrams when you draw, you need to mark the flow of current eh, starting from positive and going towards the negative. So this concept you must be very much familiar. So whatever it told you, this is a representation. This is the positive terminal of the battery. This is the positive terminal. Oh my God, 1 minute. This is the positive terminal of the battery. You can see the direction of current flow. It goes like this. Okay, but you can see the electrons are moving in the opposite direction. Electrons are moving from the negative terminal to the positive terminal. You can see this arrow mark. Okay, electrons are moving opposite to the direction of flow of current. Now, what are key learnings we had in this video? Free electrons, how they aid the current flow, and materials, some materials, not every material, some materials have copper, silver and iron. Example, they have one free electron in its outermost orbit. These free electrons need a push which is given by a battery, and the direction of flow of current is positive to negative, but electrons flow from negative to positive. So from the next video we will discuss more on a subject perspective of what is shown in a chapter. Till then, bye. Thank you.